Alright, I've had a few students request to see how this problem's done without the use of a calculator, because that calculator screen does get kind of hard to see when you have more than two of these lines that you're graphing at the same time. So this is the problem. It's I think number 5 or something like that from the homework. I went ahead and copied it over to here, everything except for well, I do have the X and Y constraint, but this is kind of a not the nicest graph paper, but this is the X-axis and the Y-axis. So this is quadrant 1 and 4, and I've excluded 3 and 2 because they're not going to be needed because X is greater than 0. Now I do have a little bit of quadrant 4, even though Y is going to be greater than 0, because we're going to have a line that we're going to need a little bit of the Y-axis for. Alright, so to be able to do this without a calculator, I mean we're just using your calculator like for arithmetic purposes, you need to come up with the X and Y intercepts of these lines. So remember, the way you do an X-intercept is when Y is equal to 0. Alright, so for the top equation, X, this one is the one we're working on now, X minus Y, I've got this highlighted. I'm just going to, for the time being, change it to equals 8 to just graph the line. Okay, so if Y is equal to 0, it's X minus 0 equals 8, or just plain X equals 8. So that means the X-intercept of this first line is 8. So there's 5, 6, 7, 8. Alright, so there's 1 point. Okay, now the Y-intercept occurs when X is equal to 0. So in this equation, if X is equal to 0, I get 0 minus Y equals 8. Divide both sides by a negative to get rid of that negative, and we get Y equals negative 8. So there's 5, 6, 7, 8. So there's the first line. Alright, now I'm going to draw it. Alright, so through those points and on and on and on and on and on. So there's our first line. Alright, so that's the X minus Y equals 8 line. Alright, same thing we can do for the next line. The X-intercept occurs when Y equals 0. So 17X plus 14, Y equals 0, so 14 times 0 equals 238. That means 17X equals 238. Alright, or divide both sides by 17, I get X equals 238 divided by 17 is 14. So 238 divided by 17 is 14. So X equals 14. I'm going to use red this time. So 14 would be, oops, there's 10, 11, 12, 13, 14. Alright, and now let X equal 0, so I got 17 times 0 plus 14, Y equals 238. Alright, that's gone, so I just have 14Y equals 238. Divide both sides by 14, and I get Y equals 238 divided by 14 is 17. Alright, so Y equals positive 17. Alright, so on this grid, here's 5, there's 10, 15, 16, 17. Yeah. Okay. So now I want to connect those with a line. Alright, and so there's the line. 17x plus 14y equals 238. Alright, and for the last one, 16x. If y equals 0, I got 16x plus 19 times 0 equals 304. So that's 16x equals 304. So divide both sides by 16. 304 divided by 16 is 19. So I get x is equal to 19. So there's 5, 10, 15, 5, 10, 15, 20, so there's 19. Alright, and then same thing, the y-intercept, set x equal to 0. So I get 16 times 0, or 0, plus 19y equals 304. Divide both sides by 19, and since 304 divided by 16 was 19, 304 divided by 19 is going to be 16. And then there's 5, 10, 15, there's 16. And I'm going to connect those two with a line. Alright, and there is our three lines. Now, we need to shade underneath these things. So we have to shade, or shade the proper regions. We have to shade, we started with the blue line, x minus 8. Let me label this green line first. That is 16x plus 19y equals 304. Okay, and starting with the blue one, we have to shade in the proper direction. Now this says less than, so it appears we'd have to shade below it, but because the y is negative, you do the opposite of what this says. So this says less than, but since the y is negative, we're actually going to shade above it. So this is shaded above in the blue. Let me do it this way. I wasn't thinking. I'll do the highlighter. The blue highlighter. So we shade above the blue line. Now another way you can determine without having to go by the signs of y and all that stuff, another thing you can do is use the origin. Alright, if the origin doesn't fall on the line, it's either in the regions to be shaded or it's not. If it's in the region to be shaded, it will make the original statement true. Okay, so the origin was in our shaded region, but that's because 0, 0 is the origin, and 0 minus 0 is 0, and 0 is less than 8. Alright, so that is shaded. Okay. If it were not, if it made it not true, then we wouldn't shade. We'd shade on the other side of the line. Alright, so that's a way you can do it without having to worry about the sign of y and flipping the order symbol and all that stuff. Just, if the origin doesn't fall on your line, use the origin to determine which way you shade. Alright, now for the next line, the red line, alright, we're going to pick again the origin. Here's the origin, and for the red line, that's the 17x plus 14y is less than 238. The origin also makes that true. Okay, so the origin makes that true, so we're going to shade on the origin side of the red line. Alright, so I'm going to shade all of this in here. Notice what we've got here. We've got this region that was just blue. Now it's a darker blue, almost a purple color, where we shaded it both blue and red. Let me do a little bit better job of shading in the blue, and you'll see what I'm talking about. So this region right here is shaded both colors, so anything that's in this dark blue shaded region satisfies both inequalities now. So just for example, 5, 5 is in both regions. 5 minus 5 is 0, and 0 is less than 8. Alright, 17 times 5 plus 14 times 5 17 times 5 plus 14 times 5 equals 155, and that is less than 238. So again, all these things that are shaded in this darker color satisfy both inequalities so far. Anything that's in one but not the other, like for instance 5, 10, 10, 0 satisfies this one. 10 times 17 is 170 plus 0 is less than 238, but 10 minus 0 is 10, and 10 is not less than 8, so it's not shaded in both regions. Okay, so what we're doing is we're creating a region that's going to satisfy all of these. Alright, now moving on to the green one. Again, if I use the origin, there's the origin right here. Does that satisfy the inequality? Is 16 times 0, which is 0, plus 19 times 0, which is also 0. So is 0 plus 0 less than 304? Yes. 0 is less than 304, so everything on the origin side of the green line should also be shaded. So I'm going to shade all it in. Actually, I'll just make little circles for it because you can't really tell a difference between that color and that color. So I'm just going to make little circles for the green. So all of this is in the green, underneath the green line. All the way through. Alright, so here's what it looks like when we're done. Now, what we're after, if you think about it, we want the thing that satisfies all three. So that's going to be the dark blue with the dots in it. Alright, that's what satisfies all three things. So I'm going to shade in or darken in the corner points of that, because that's going to be our test point. So it's that point right there. Oops, sorry, that's doesn't satisfy this part. I meant to get that in a second. It has to be x greater than 0, y greater than 0. So because of that, I'm going to shade in our boundary. So it has to be greater than, y has to be greater than 0, so that's along the x-axis. Alright, so there to there. Alright, and then there to there, where the blue line and the red line intersect. And then from there up to there, where the green and the red intersect. Right, and then finally from there to there, the y-intercept of the green line. Right, and then finally come down to the origin. Alright, so there's my regions. That's the region, sorry, that satisfies all parts of this, including this part. Again, the only reason I included all this stuff down here was because of that y-intercept that we needed to graph this first line. But there is the boundary that satisfy all parts of this of these constraints. Okay, now what we talked about in the last section and part of this section is whatever maximizes this thing, whatever maximizes the original equation up here. this function. Whatever maximizes that has to be a corner point of this region right here. So what are the corner points? The corner points are anywhere it takes a turn. So right here is a corner point. The origin is a corner point that a lot of people forget about. This is a corner point. There's a corner point. And this little subtle corner point where the red and the green line intersect. Now what are the corner points made up of? They are made up of x-intercepts, y-intercepts, and intersections of the lines. Okay? X-intercepts, y-intercepts, and the intersections of the lines. So what do we have to find? You might want to make yourself a little note of what you have to find. So there, let's call this the first point that we had to find. All right, what is it? It's the y-intercept of which line? The green line. All right, because there's the y-intercept of the red line right there. So this is the y-intercept of this green line, which is 16x plus 19y equals 304. All right. The y-intercept of the green line, if you go back and look at it, was y equals 16. So 0, 16 is one of our points. Let me just keep a running tab of them. Alright, so 0, 16 is a point to optimize or to check. Right. We also need, there's the origin. That's an easy one to find. So there's the origin. Okay, we need to find the x-intercept here, which is the x-intercept of the blue line. Right, the x-intercept of the blue line was x equals 8. Again, we found it earlier. So 8, 0 is a point to check. Alright, and what does that leave? That only leaves these last two, this one and this one. The little subtle one right here that's hard to see, and then this one. We got to find both of those. Alright, this one is the intersection of the red line and the blue line. So if you only want to plot those two on your calculator and find the intersection, you can, or you can do it by hand. It's just a system of equations you'd have to solve. So to do it just strictly by hand, x minus y equals 8. That's the blue line, and we're finding where the blue line crosses the red line. And then 17x plus 14y equals 238. Alright, I'm going to multiply the top equation by 14, alright, to get a cancellation to occur here. So that's 14x minus 14y equals 8 times 14 is 2, carry 3, 1, 12. And then 17x, just bring that over, plus 14y equals 238. Alright, add these equations. You get 31x. These cancel. Equals 10, 5, 350. That's 350. Alright, and then $350 divided by 31 is 350 over 31. I was thinking that wasn't going to reduce. So the x coordinate equals 350 over 31. Alright, and then how do I find the y coordinate? Well, right there is a y in an equation with x. Alright, so we need to subtract 350 over 31. Or sorry, we need to plug that in for x. So that's 350 over 31. Alright, we're just plugging into this equation here. Minus y equals 8. Alright, I'm going to bring y over and then subtract 8 over. Alright, the y cancels here, the 8 cancels here, and I get y equals 350 over 31 minus 8. Alright, which equals, I'm going to do it on the calculator, 350 over 31 minus 8. Enter, change it to a fraction. So 102 over 31. Over 31. So there's another point to check. 350 over 31, 102 over 31. Alright, and then lastly, this point. The point where the green line crosses the red line. Alright, now, if you want to do a little bit of it on your calculator, I don't blame you. I would, personally, myself. Because it's, you know, as you can see, it's you know, doing it by hand is not the prettiest mathematics always. You're solving systems, but I mean it's definitely doable. So it's just completely up to you, however you want to go about doing it. I'm going to show you how to do that part of it on the calculator if you want. Alright, now I have the 3 lines on here, okay, that we use to graph them. Solved for y, and we're looking for where 17x plus 14y, that's this one that has the 17 and the 14, crosses 16x plus 19y, so that's going to be this one. So I come in here, I'm going to turn off the other line that I don't need by hitting enter while I got it highlighted on the equals, and I'm going to turn this one on by doing the same thing, hitting graph. So there's the 2 lines, they intersect right here. I'm going to highlight intersect, option 5. First curve is this line. Alright, that's the one with the 17 and the 14. Alright, second curve, that's the other line with the 16 and the 19, and it looks like they intersect about right there. Now, it's going to give you these decimals. Okay? Now, once you get the decimals, once it returns the decimals, hit second mode to go back to the home screen, and you want to know what x is as a fraction. So press X, the X button, and then press Math, option 1, change it to a fraction, and there's that one as a fraction. And then the other variable was y, so press alpha, there's y above 1, they're the same thing, Math 1, change it to a fraction, and there's the y coordinate. So 266 99, or 266 99ths. And 1360 99ths. Alright, I'm going to write this one down here just to have them all big enough for me to see them. Alright, so these are, again, the 5 points that we need to check. Okay, they're the 1, 2, 3, 4, 5 points that are on these bounds. 1, 2, 3, 4, 5. Now, one of them is going to make this thing biggest that it can possibly be. So just start plugging them in. Alright, so Z is what we're trying to maximize here, so we're going to put in 3 parentheses and then just start with any one point you want to use. 0, 16. Alright, 0 plus 3 times 16. Alright, that made it 48. Obviously 0, 0 is going to make that sum equal to 0, so we're trying to maximize it, so that's not going to work. Alright, do it again with 8, 0. So change this to 8. Change this to 0. You can hit delete and then 0. That makes that 24, so it's not going to be that one. Alright, you can kind of eliminate them as you go. That's out, that's obviously out. Alright, do it again. This time we're going to put in 266 over 99 for x, and then the same thing 3 times 1360 over 99 for y. Hit enter. So it's a little bit bigger, so that's going to eliminate the 016. Alright, 350 over 31. And delete 102 over 31. So 43.7, so that's out, and that means this is the point that maximizes it. So this is the point that we're after. Alright, that was the this intersection right here, I believe. Alright, so that is this point right here. The max occurs here at 266/99 and 1360/99. Alright, so the maximum is, we did that on the calculator just a little bit ago. Just hitting second enter until I get back to the problem that maximized it. That one. Again, math 1 to change it to a fraction when your decimal repeats. So 542 over 11. Alright, when x equals 266 over 99. Alright, and y equals 1360 over 99. Alright, another thing you can do, this is just completely optional. If you want to try it though, it's fine to do it. In your stat menu, once you've come up with your points to try, you can go to your editor and put in all the x coordinates in L1. So 0, 0, 8, 266 over 99, and then 350 over 31. Alright, then go over and put all your y's in L2. So 16, 0, 0, 1360 over 99, and then 102 over 31. Alright, and once you've got those in there, hit second mode to leave. Alright, and then type in this. Type 3. We're doing 3x plus 3y. We're back to this. 3 L1 is where we have the x's, plus 3L2. Okay, so that's 3 times the x's plus 3 times the y's, and then do this. Tell it to store your answers, store in second 3, list 3. And then you hit enter. It's going to do this, and then press your stat button to go back. And there's the numbers, and we can see here now that this is the maximum and occurs with these values right here. Right, and that was the 266 over 99, the 1360 over 99. It's going to automatically put them in there as decimals, but that's how you can use the list menu to come up. You can see the maximum, you can see the minimum right there on your list menu. So that's an option too if you want to practice some other things with your calculator. But again, some people ask about looking at an example doing it by hand. So there's how you would do it by hand. You're more than welcome to do them by hand. It is a little more time consuming. If you can get yourself used to using the calculator and using the intersect feature on your calculator, when you do this, like I've got these in here with the shaded regions now, so when I graph it, you know, it does make it hard to see the intersections. Now sometimes you can see the intersections as clear as a bell. It's just because these two were so close together. You remember the y-intercept here was 16 and 17. But if it makes it hard to see where the intersections are, go back and turn the shading off. Just take it back to regular lines. And if that helps, you know, if that helps you see it, then that's as long as you understand, you know what the regions are, how to find what to shade. You know, yeah, you can see them a lot better where these things intersect if it's just lines there. Okay, there's an intersection there, there's an intersection there, there's an intersection there. Alright, but it is important that you do understand that this is what would be shaded. So it may, you may want to do like a combo of the two. You know, have it shaded, take the shading away, bring the shading back as needed, or just do it by hand. Right? You've seen an example how to do it by hand. You're just doing the intersections of lines. That's basically what you're doing, and finding all those corner points to check in your equation to be maximized or minimized.